Gödel's incompleteness theorem. The relativist gestalt was powerfully reinforced in 1931 by Kurt Gödel's incompleteness theorem, one of the 20th century's most sublime and devastating pieces of logic. Gödel may quite possibly have been the most eccentric of top 20th century scientists, easily trumping his friend Einstein. After working in Vienna from 1924 on, Gödel fled to Princeton in 1938. The attempt to secure him American citizenship barely survived his long and pedantic exposition of the many grave flaws in the U.S. Constitution. He eventually starved himself to death, convinced that his food was being poisoned. Gödel's incompleteness theorem shattered the dreams of mathematicians by demonstrating that, even in a very simple system like arithmetic, statements could be written down that could neither be proved nor disproved within the rules of that system. Any consistent numerical system generates formulae. To take two simple examples, a number is equal to itself, or 0 is a number, that cannot be proved except by importing axioms from outside the system. Gödel's proof was not confined to mathematics. Reality, he demonstrated, is a construct, not a given. One implication is that the very process of thinking adds to what we think about, and the process can never be completed. No finite language or system can capture all truth. So, Gödel's theorem really takes the implications of Einstein's theories of relativity one stage further. We can dismiss the possibility of absolute truth. Incidentally, in 1949, Gödel solved Einstein's general relativity equations in such a way that the entire universe is rotating and time travel entirely feasible. It is unlikely, however, that Gödel's solution is correct, since his universe was not expanding, and ours almost certainly is. Relativity in business. Relativity, and the absence of absolute truth, should be a central tenet in business. Just to mention some of the important relativities. 1. A customer's perspective will always be different from the supplier's. Often the differences are large. In the 2 decades when I was a consultant, I never found that the client's view of what his customers wanted was entirely the same as the customer's view. The only antidote is to keep asking the customers what they want and how good you and your main competitors are on each desired dimension, and to listen to what the customers say, and to act on it. This is 80% of what good business is about, and very few people do it well. And 2, your firm's perspective on what customers want will always be different from the customer's perspective. This is the inverse of the first point, and, here is the rub, it will be wrong in proposition to the distance of the executive from the customer front line. This is a problem because decisions tend to be taken well away from the customer front line. Decisions are usually taken in the chief executive suite or the boardroom. The decisions are meant to benefit the customer. Given the distance and the differences in perspective, it is a safe bet that the decisions won't achieve the desired effect. There are 2 remedies. 1 is to move the decisions closer to the customer, ideally to have the decisions made by the people who deal with customers daily, or, even radical heresy, by the customers themselves. I don't mean decisions on issues such as pricing, where the customer's interests conflict with the supplier's. I do mean decisions on new products, on how production and service are organized, and on everything to do with customer value except pricing and margin decisions. The other remedy is to ensure that the decision makers, especially the chief executive, are in daily contact with customers. In my experience, the first remedy, although radical, is more realistic than the second. American humorist Dave Barry makes the point tellingly. He writes, "My theory is that the most hated group in any large company is the customers. They don't know about company procedures or anything about what you do, which drives you crazy. At the same time, your bosses, who are idiots, who don't have to talk to customers, tell you day in and day out that the most important person in the world is the customer." There is no absolute product quality. It is all perception. The customer's view about product quality is unlikely to be the same as yours. In fact, customers, another heresy, may not care very much about quality. Even if they do, other things may be confused with quality or imputed to quality. A terrific brand, brilliant advertising, stunning service, fast delivery, or plain and simple market leadership, all these may be confused with quality. Clearly, some quality differences are so marked as to be indisputable. A Cartier watch is better quality than a Swatch. A Mont Blanc pen is superior quality to a Bic ballpoint. But when products are more similar, perceptions of quality may be more important than objective differences. Are McDonald's burgers really better quality than those from Burger King? Is a Coke better quality than a Pepsi? Is an Agatha Christie murder story better quality than one from Niall Marsh? Remember that quality is a means to an end, not an end in itself. Quality is what the customer likes, and if your customers don't value quality, spend your effort on something else that they like more. Your main competitor's perspective will not be the same as your own. Don't imagine that your rival will think like you, or even interpret the same data the same way you do. Try to get inside his head. If this is impossible, just observe what he does and draw inferences about how his worldview is different from yours. The medium is the message. A final important relativist insight comes from Marshall McLuhan, English professor turned media guru. In his path-breaking 1964 book titled Understanding Media, The Extensions of Man, he writes, "In a culture like ours, long accustomed to splitting and dividing things as means of control, it is sometimes a bit of a shock to be reminded that, in operational and practical fact, the medium is the message. The personal and social consequences of any medium, that is, of any extension of ourselves, result from the new scale this is introduced into our efforts by each extension of ourselves, or by any new technology." What McLuhan means is that media are not neutral. They have their own message and effects, quite independent of content, and often more important than the specific content. The invention of writing facilitated the widespread development of rational and analytical thought. The printing press and printed books, a new medium, had profound consequences. People did not have to go to church to read the Bible, or rely on a priest to interpret it for them. They could read it themselves and develop their own interpretation. It is therefore not fanciful to link Protestantism and individualism together with a change in the medium, the advent of mass-produced, cheaper books. The medium was more important than the message. The Bible, for example, which of course had not changed. When television arrived, it had an enormous social impact, quite independent of the content of broadcasting. The medium itself elevated visual impact, downgraded thought, and collapsed time and space by bringing centuries of history and news from around the world into everyone's living room. TV is a cool medium, not in the modern sense, but in that it cools down its content, taking the edge off bloody conflict and splicing it with sexy Levi's commercials. TV is, or was, a one-way medium that gives enormous power to image makers and broadcasters, and arguably, my opinion rather than McLuhan's, reversed a century of progress in widening and deepening the intellectual powers of ordinary people. The content can be excellent and intellectual, but the passive nature of traditional television viewing and the inherent preference given to image and emotion over substance and reason corrode thought and creativity. The medium is the message. The Internet as new medium and new message. What is great about new media, however, is that they don't stand still. Cheap telecommunications, a large fax network, and above all, the Internet, are going to transform society at least as profoundly as television, but much more constructively. The Internet is a rich medium that connects individuals to other individuals, businesses to each other, and individuals to businesses. Unlike TV, which was biased toward the center of society and was very much dos tombant, the Internet shifts power to individuals and consumers, away from governments, image makers, elites, and big business. The Internet favors individual thought and action. It gives power to entrepreneurs and insurgent businesses, and takes power away from established corporations with physical assets and legacy mindsets. Previous media revolutions had a significant impact on business. Television promoted mass marketing and increased the advantages of global scale and consumer goods, but even more impact on society as a whole. The Internet will have a terrific effect on society, but may well change business to an even greater extent. Here, the medium really is the message. For those in business, it is wrong to think about the Internet primarily as a channel of distribution. It will change the nature of business and the specifics of competition in any business in a much more radical way. Those who grasp the enormity of the change, and that the medium is the message, will have an enormous advantage over those who don't. Summary. The theory of relativity tells us that time is not an independent variable in business. It is part of what we offer. Time is product. Time is service. Time is money. Time is competitive advantage. Time is abundant. Organizations and executives waste tremendous amounts of time. When they really want to add value, they do so very quickly and efficiently. Organizational life normally consists of a few islands of high customer value surrounded by oceans of corporate bilge. The typical firm could do things that mattered to customers 2 to 3 times faster. Relativity tells us that objective reality is a mirage. We make our own reality. The future is not the past run backwards. The future is what we make it. There are many potential futures. There are multiple routes to success. The raw material of success is all around us, lying unused. The medium is the message. Business and society are profoundly affected by major revolutions in technology, particularly communications technology. The invention of writing was one such revolution. So were the printing press and the rise of the book industry. So is television. So is the Internet. These revolutions transform our senses. They alter our relationship to space and time. They change the way we interact with each other, the sort of people we think we are, and the sort of things we think we should do. They shift the balance of power in society. The Internet is changing the nature of business reality. The Internet makes it imperative that we think in terms of product time, and service time, and that we find new ways to deliver far more rich value to far more customers at far less cost, far more quickly. The old absolutes of business are gone. There is a brave new world to fear and to create. Action implications. 1. Think service time. Dramatically reduce the time you take to deliver products and services to your customers. Think not of products and time, but product time. Not service and time, but service time. 2. Realize that customers' and competitors' perspectives will always be different from your own. Struggle to understand their viewpoints. Influence the customer's view by being there, molding customer perception even as it is being formed. Don't understand it. Define it. Change it. Create it. Live it. And finally, 3. Grasp some of the ways in which the new medium of the Internet could change the message, the commercial reality, for your industry, your business, and your career. Find ways to deliver far more rich and individualized value to far more customers at far lower cost and far greater speed. If you can't, then found a new business or find a new career. Chapter 8. On Quantum Mechanics. Quantum mechanics surpasses any other conceptual breakthrough in the breadth of its scientific ramifications and in the jolt its counterintuitive consequences gave to our view of nature. The micro-world is fully as strange as the cosmos. Professor Sir Martin Rees, the UK's Astronomer Royal. The opposite of a trivial truth is plainful false. The opposite of a great truth is also true. Niels Bohr. The most majestic triumph of 20th century science. Relativity theory is odd enough, and yet it gets weirder. Take a deep breath. Quantum mechanics, also known as quantum physics or quantum theory, is the jewel in the crown of 20th century science, the most majestic triumph of insight and intellect. Quantum theory shows how the universe, at its most fundamental level, really works. Yet it is not a comfortable ride. Even Einstein found quantum theory so strange and subversive that he refused to accept it at all, comparing it to the system of delusions of an exceedingly intelligent paranoiac. Hence his famous and wrong observation that God does not play dice with the universe. So what is quantum physics, and how was it discovered? Niels Bohr and the Quantum Leap. The great Danish physicist Niels Bohr, 1885 to 1962, first realized around 1912 to 1913 that Newtonian mechanics could not explain how atoms behave. Ernest Rutherford, 1871 to 1937, had already developed a model of the atom as a miniature solar system with a tiny nucleus of protons and neutrons orbited by even smaller electrons. It was already known that atoms were unstable. Bohr guessed that electrons changed orbit when they radiated light. He therefore identified the emission of a quantum with the jump of an electron from one orbit to another. According to Bohr's model, electrons excited by a bombardment of energy may leap from one orbit to another orbit, be it inner or outer, instantly passing from one position to another non-adjacent position without passing physically in between. This led to the hypothesis that when an atom has a choice of states to leap into, it decides entirely at random. A quantum leap, or jump, the term physicists prefer, is the smallest change that can be made, and it happens unpredictably. Over the next 2 decades, mathematical modeling of the atom led to new and counterintuitive insights. 2 of the most important of these were Heisenberg's uncertainty principle and Bohr's principle of complementarity. Let's take a look at each. Heisenberg's uncertainty principle. In 1927, Werner Heisenberg proved that uncertainty is inherent in the equations of quantum mechanics. He showed that if we try to measure both the position and the momentum of an electron, we will fail. The more accurately we know where the object is, the less certain we can be of its momentum, and the other way around. The uncertainty principle therefore states that it is not possible to calculate accurately both the position and the momentum of a subatomic particle. Language cannot effectively describe the atom. All we can do is measure the atom, but only with inherent uncertainty. This is not because of any defect in our measuring techniques. It is because of a fundamental fuzziness in how tiny matter behaves. We will never know whether atoms do or do not behave like precise points moving at precise speeds. Heisenberg therefore slammed the assumption that behind the statistical universe of perception there lies hidden a real world ruled by causality as useless and meaningless. The principle of complementarity, wave-particle duality. In 1927, Bohr expounded his principle that light is both wave-like and particle-like simultaneously. The reality detected depends on the experimenter and his method. If you observe a photon with a particle detector, you get a particle. Observe the photon with a wave detector and, hey presto, you get a wave. Neither, Bohr said, is more real or accurate. We can only see a wave or a particle at any one time, yet both descriptions are necessary to get a full sense of what light is. The 2 methods complement each other. Both and becomes a better perspective than either or. Schrödinger's cat. Erwin Schrödinger, 1887 to 1961, was a colorful Austrian physicist who in 1925 created the wave equation describing the electron's behavior around the atomic nucleus. Bohr told Schrödinger, "Your wave mechanics has contributed so much to mathematical clarity and simplicity that it represents gigantic progress over all previous forms of quantum mechanics." Nevertheless, Schrödinger, like Einstein, was upset by the failure to find an underlying cause of atomic and subatomic behavior. Einstein and Schrödinger both wanted to detect the underlying reality that they supposed must exist below the unreal world of the quantum. To demonstrate the absurdity of quantum theory's probabilistic conclusions, Schrödinger created the parable of the cat that is both dead and alive. His thought experiment goes like this. Imagine a live cat in a black box, which we can't see into. The box also contains a vial of poison that, if released, will kill the cat. There is a 50-50 chance that radioactive decay will release the poison. Common sense suggests that, at any moment, the cat is either dead or alive. Either the poison has been released or it hasn't. The fact that we don't know whether the cat is dead or alive is irrelevant. It's either quite happy or quite dead. Yet, quantum theory says that the radioactive material does not decide whether to decay or not until it is observed. Until we open the box, therefore, according to quantum theory, The atomic decay has neither happened nor not happened. The cat, in turn, therefore, can neither be dead nor alive. It must be both dead and alive. Only by opening the box do we make it dead or alive. Pretty silly? Schrödinger thought so. What he highlighted was the gap between quantum reality, the world of very small pieces of matter, and reality beyond the micro-world, that is, the everyday reality of cats and people and anything bigger than an atom. But although he would have liked to, Schrödinger did not disprove the nature of quantum reality. Experiments have proved beyond any doubt that quantum mechanics is correct in saying that photon particles behave randomly, and yet in a related manner. One photon has an instantaneous effect on another photon, even when logically it can't. The fundamental particles that make up the world seem to be inseparably connected to each other, part of some indivisible whole. The particles know what the others are doing. What I think Schrödinger's parable of the cat does succeed in doing is to question the relevance of quantum theory to phenomena outside the quantum world, and to inject some cautious common sense into any attempt to extrapolate from the micro world. How relevant is quantum theory in the non-micro world? Quantum mechanics has many puzzling paradoxes, but one that is of particular interest is the contrast between the impressive practical results of the theory on the one hand, and its mysterious, spooky, and apparently illogical nature on the other hand. No one would believe quantum theory if its scientific predictions had not been validated so many times, or if it had not changed our lives so profoundly. Quantum theory can predict experimental results to many decimal places. Quantum theory and relativity have given us the transistor, the microchip, nuclear power, and lasers. Modern cosmology would be impossible without quantum theory. Here we have this amazingly successful physical theory, and yet the implications of quantum theory, even within science, and within the science of microscopic pieces of matter, appear very fuzzy, peculiar, and wrong-headed, even to eminent physicists such as Einstein and Schrödinger. So the question we must now pose is, how relevant is quantum mechanics to anything else, and specifically to business? Here we must wade into the choppy waters of controversy. Various far-reaching interpretations of quantum theory have been given by writers on pop science, some of whom claim that there is a new quantum theory of society and business that replaces the allegedly dominant Newtonian theories. I find these claims unconvincing, for reasons I'll cover later in this chapter. Before outlining a good example of quantum theory extrapolated to business, and challenging this interpretation, I would like first to draw out two positive points where I think it is valid and instructive to use quantum theory as a metaphor for business purposes. Escaping the tyranny of either or. Both Heisenberg's uncertainty principle and Bohr's principle of complementarity are direct exponents of something that was, at the time, in the 1920s, new science. A both and rather than an either or approach. The methodology was a response to the nature of quantum reality. Whereas it would make no sense to say, for example, that a cat was both in the drawing room and in the bedroom simultaneously, it does make some sort of sense, according to Heisenberg, to say that a particle could be in two places at once. At least, given the existence of quantum leaps and discontinuities within atoms, we cannot visualize accurately their position and the momentum. And, Bohr adds, light can both be a series of waves and a stream of particles at the same time, Both descriptions, Bohr says, are necessary and complementary to help us understand what is going on. The discovery of both and as a sensible alternative to either or is, I believe, a valid and relatively novel way of thinking that can be derived, at least loosely, from quantum mechanics. Of course, if quantum mechanics had never existed, we could still have made the mental breakthrough to both and thinking. For one thing, we could have deduced both and thinking from modern business itself. Name almost any trade-off that used to be regarded as an either-or issue, and it can be shown that, at least in some circumstances, the trade-off can be avoided and a both-and solution created. For example, if we are sufficiently creative or lucky, we can both keep the stock market happy and be socially responsible. We can both aim for high profits and deliver top value to customers. We can have both high quality and low costs. Quality may not just be free, but actually have negative costs. You can gain from a particular transaction, and so can I. In the economy at large, we can now apparently even have high growth and low unemployment. We can also enjoy high growth and low inflation, and low unemployment and low inflation. Previously inevitable trade-offs can now sometimes be transcended. Whenever a trade-off is proposed, we should assume that there is a way around it, so that we can have our cake and eat it. There probably is, if we are creative enough. Testing out multiple possible options. A second useful, although admittedly weaker, point is an analogy between the behavior of electrons or photons and the value of testing out multiple possible options. Here I would like to quote Dana Zohar and Ian Marshall, writers of popular books on quantum theory and its social implications. They write, "The atom may become unstable for no apparent reason. So, quite suddenly, the electrons in a previously stable atom may begin to move into different energy orbits. There is no way of knowing by which path a particular electron may travel. Indeterminacy, the lack of any physical basis for predicting the outcome of events, characterizes the quantum realm. The electron may go to the next highest state. It may leap over several intermediate states, or even double back on itself. Quantum physics tells us that the electron actually follows all these possible paths, all at the same time. It behaves as though it is smeared out all over time and space, and everywhere at once. In much the same way as we play with multiple possibilities in our imaginations, or launch trial balloons to see how something might work out, the electron puts out feelers to see which path ultimately suits it best." The business analogy is that we should conduct thought experiments and actual experiments before settling on an important course of action. Imagine doing A, B, and C, and also doing X, Y, and Z. Neither you nor your firm is predestined to pursue one course of action. You have very many degrees of freedom, bounded only by your imagination. There is always another path, always another way of doing things, always someplace else to go. Create many possibilities. Play with them in your mind. Consult colleagues. Think the unthought. Think the unthinkable. No other choice, but don't fix yet on one course of action. Keep a few in your locker. Now, put out feelers to collaborators and to the marketplace. Ask distributors, suppliers, customers, trusted experts. What do you think about X? Would you like Y? What would be the reaction if we W plus Z, but also minus B? Even now, do not decide what you are going to do. Launch test markets to see whether the concept, technology, and product variants can meet the product concept expectations, and whether the product is sustainable, whether there is a sufficiently high level of repurchase. See which trial balloons go up and stay up, which go down, which go nowhere. Experiment without commitment. Now revise your plans. Conduct more experiments. Iterate. When you are ready, go. But not until you have behaved as if you were an electron. Quantum theory used as a battering ram. I think that these two examples of management insight from quantum mechanics, the both-and point, and the idea of putting out feelers before moving decisively, are reasonable and helpful analogies for business from the micro world. But several writers have gone further and attempted to use quantum mechanics as a battering ram to attack the Newtonian worldview and support what we may loosely term a New Age philosophy of society and business, based allegedly on quantum physics. This New Age use of quantum theory is interesting, bold, and coherent. It is also wrong. After describing the new view, there are three issues that I would like to pursue. One is whether the New Age view can derive legitimacy from quantum physics. The second issue is whether, regardless of its provenance, the new view deserves the attention of business people, whether it contains helpful insights. A final question is whether the new view is really consistent with the most important positive insight that can legitimately be drawn from quantum mechanics. First, the description. For many years, the leading exponent of the New Age view of quantum physics, although I think she would repudiate the New Age tag, has been Dana Zohar, a writer who has studied physics, philosophy, and religion. Her views are clearly expressed in three intriguing books titled The Quantum Self, The Quantum Society, and Rewiring the Corporate Brain. In The Quantum Society, she writes, I believe we must come to appreciate that self, society, and nature all derive from a common source, that each is a necessary partner in some larger creative dialogue. There is just one reality, and we are part of it. Physics tells us about the processes of creativity and transformation in the natural world. If we understand the actual physical basis of transformation, perhaps we can align ourselves with it. Physics tells us about the processes of creativity and transformation in the natural world. If we understand the actual physical basis of transformation, perhaps we can align ourselves with it. Quantum physics in particular almost cries out for use as a more general model for a whole new kind of thinking about ourselves and our experience. There is an uncanny and intriguing similarity between the way that quantum systems relate and behave and so much that we are now beginning to understand or hope for about human social relations. In Rewiring the Corporate Brain, Zohar describes the choice between Newtonian management and quantum leadership. In a management leadership chart, she says, Newtonian management stresses certainty, predictability, hierarchy, division of labor, or function fragmentation. Power emanates from top or center. Employees are passive units of production. Single viewpoint, one best way, competition, inflexible structures, heavy on bureaucratic control, efficiency, and top-down reactive operation. By way of contrast, she writes, quantum management stresses uncertainty, rapid change, unpredictability, non-hierarchical networks, multifunctional and holistic, that is, integrated effort. Power emanates from many interacting centers. Employees are co-creative partners, many viewpoints. Many ways of getting things done: cooperation, responsive, and flexible structures, hands-off supervision, meaningful service and relationships, and bottom-up, that is, experimental, operation. Does quantum theory sustain a new view of management? Let us leave aside for the moment the question of whether quantum management is better than Newtonian management. The first issue is whether quantum management can reasonably be derived from quantum theory. I have allowed previously that it is reasonable to derive from quantum theory, by way of analogy, 2 of the 11 points that Zohar makes about quantum management, namely, what we have called both and, which she calls here many viewpoints, and the point about experiments. I can also see that analogies with the behavior of the microworld can just about sustain the points about uncertainty and rapid change and unpredictability, although many other observations from the natural world would make the point about uncertainty equally well. And while it is clear that the microworld is, to us, unpredictable, I am not sure that it typically demonstrates rapid change. Let us, however, give the benefit of the doubt here. But is there anything at all in quantum physics that demonstrates non-hierarchical networks, or multifunctional and holistic, that is, integrated effort, or that power emanates from many interacting centers, or that employees are co-creative partners, or cooperation, or responsible and flexible structures, hands-off supervision, or meaningful service and relationships, or indeed the bottom-up part of bottom-up experimental operations? It may be my lack of expertise in quantum mechanics that leads to my puzzlement, but having read many accounts of quantum theory, I can see no shred of evidence that it supports these latter points about quantum management in any way whatsoever. No doubt Zohar would claim that the important thing is not the particulars but the general gestalt of quantum physics and other 20th century science, as opposed to Newtonian physics. And here there is something of a point. Newtonian physics did crystallize and popularize the mechanical view of the world, the idea that the world and its parts were a series of machines that behaved predictably and in an orderly fashion. Quantum physics, in partial contrast, reveals that some parts of reality, namely submicroscopic and inanimate particles and their ilk, behave in a way that is difficult for us to predict, and that certainly cannot be characterized as machine-like. Is this a sufficient basis for a new world view? And can it then be reasonably extrapolated to give a new view of management? Not, in my view, without a lot of help and bucket loads of imagination. Some help, it is true, comes from other 20th century science, from some that we have looked at already, relativity and Gödel's incompleteness theorem, and some that we shall examine in Part 3, namely the concepts of chaos, complexity, and nonlinear systems generally. Together, these do reveal that there are important parts of the natural world that behave in interesting patterns that are not linear or mechanical, and are often difficult to understand at all. We have also seen that 19th and 20th century biology supports the importance of cooperation, mentioned by Zohar, and variation, not given prominence by her. But is it fair to put all this together in the Zoharian cocktail of quantum management, which is implicitly good, and contrast it all to Newtonian management, implicitly bad? I would say, at the very least, that the case is not proven. I would also make the very important point that quantum physics does not replace Newtonian physics, which remains valid, or only very slightly inaccurate for everything that it always covered. Does this imply that Newtonian management is almost perfectly valid for large parts of our experience too? Is quantum management better than Newtonian management? The second issue we should briefly consider is whether quantum management is a useful business philosophy, regardless of whether it does or does not fairly derive from quantum physics. Quantum management is a mixed bag of attributes, some of which are certainly useful in particular circumstances. But it is interesting that there is no example on Earth of a business organization that is run more on quantum management than Newtonian management lines. Of course, this could just be timidity and unfamiliarity with the new paradigm, but it could equally well be because the task is impossible. Is quantum management really compatible with valid insights from quantum theory? This is our third and final issue. For me, the key insight that can directly be drawn from quantum mechanics is that, wherever possible, we should adopt a both-and approach to business, escaping the tyranny of either-or. And here it is deeply ironic that expositions of quantum thinking, like those of Dana Zohar, should take such pains to denigrate Newtonian mechanistic thinking. The paradoxical implication is that we can have either Newtonian management or quantum management. This is doubly inappropriate. The choice we have is not between Newtonian physics and quantum physics. We need them both. And we are not forced to choose between the Newtonian worldview, or a so-called Newtonian view of management, and the perspectives given by quantum theory and other 20th century science. We can benefit from both. The appropriate view, surely, is that quantum theory reveals another world, a parallel universe that we cannot directly experience, another set of insights and language, a world from which we can draw insight and inspiration, but which cannot and should not replace the Newtonian world of rational thought, plans, objectives, solid engineering, numbers, budgets, and a quest for high returns. Quantum thinking has a valuable role in supplementing this approach, in drawing attention to its flaws, and in stimulating the imagination. But quantum thinking alone can't supply a way of managing a business organization, any more than it can build a bridge or send someone to Mars. We do quantum physics and quantum thinking no favors by exaggerating its reach or comprehensiveness, or by setting it up as a complete replacement for Newtonian methods. The insistence by some writers that the quantum way is the true way, and the extrapolation of quantum reality to cover all reality, runs directly counter to the more tolerant and inclusive wisdom of Niels Bohr, probably the greatest quantum physicist ever, who insisted that the opposite of a great truth is also true. The quantum world is not better or worse than the Newtonian world. It is just different. Vive la différence! Summary. Quantum mechanics shows how the smallest particles of matter behave. The answer is, oddly, unpredictably, bizarrely. Werner Heisenberg showed that uncertainty is inherent in quantum mechanics. We cannot follow the position and momentum of electrons. They seem to move in different directions at random, and even simultaneously. Niels Bohr showed that light is, simultaneously, both like a wave and like a particle. Both descriptions are necessary and complementary for us to grasp what is happening in the micro world. Erwin Schrödinger's parable of the cat shows the gulf that separates quantum theory's indeterminate conclusions from the reality of ordinary life beyond the micro world. We must be cautious in extrapolating from quantum theory. the mysterious world of microscopic, inanimate particles adds a new perspective on life, but it does not invalidate other, more straightforward perspectives. Even in physics, quantum mechanics supplements, but does not replace Newtonian mechanics. Quantum theory supplies extremely minor adjustments to Newtonian calculations, adjustments that for nearly all practical applications can be safely ignored. Quantum theory is a marvelous triumph of the intellect and has led to computers, biotechnology, and genetic engineering, yet its impact on mainstream engineering has been slight. Attempts to use quantum theory as a battering ram to attack Newtonian mechanical attitudes and ways of behavior are unconvincing. Such attempts betray a shallow understanding of the nature of science and business alike, and would probably have been repudiated by the fathers of quantum theory itself. Two important insights for business may, however, be reasonably drawn from quantum theory. If light can be visualized both as a series of waves and as a stream of particles, then any one view of business activity is likely to be restrictive. For example, business can legitimately be viewed as an economic exercise to maximize profits and cash. But this does not preclude the simultaneous legitimacy of an alternative view, for example, that business is a creative social activity that exists to add value to customers. These perspectives appear to be incompatible, but they may actually be complementary. By extension, and using a little poetic license, we could generalize that quantum theory implies that the world is not either-or. It is both and. Contradictions can be transcended. With enough imagination, no trade-offs may be inevitable. The second valid insight is the value of testing out possible multiple options. As far as we can tell, electrons can and do go anywhere and everywhere all at once. We can too, via thought experiments. These can be followed by putting out feelers to the market and launching some trial balloons. A useful rule of thumb may therefore be, don't commit major resources until you've lived like an electron. Action implications. 1. Pursue both and. Don't believe that contradictions and trade-offs are inevitable. Be creative in seeking ways to diffuse and defeat them, so that you can deliver the best of both worlds. Escape from the limitations of either-or thinking. Have it all. And 2. Experiment in thought and deed before you commit yourself to a major initiative. Part 2, Concluding Note. In Part 2, we've examined two different types of physics, two different worldviews, and by implication, two different views of organizations and management. It's odd that the same physical science can give rise, sequentially, to two such different views of how the world works. And on reflection, the new world of quantum physics, with its fresh and subversive implications for how the universe works, supplements but does not replace its older cousin, the physics derived from Isaac Newton. Chapter 6 celebrated the Newtonian model and the power of numbers, analysis, and simple ratios comparing two key relationships. Here lie the origins of accounting systems, profitability analyses, and 2x2 matrices. Their power is not to be sneered at. We examined one such powerful relationship, that between profitability and the distance from competitors and their relative size. While the extent to which the relationship works mathematically is unproven, we explored the intuitive appeal of the concept of the gravity of competition, where competition from near and similar business units depresses returns. We posited that the way to earn very high returns on capital was to establish the maximum possible distance from competitors along the dimensions of customer type, product type, and geography. Chapter 7's review of relativity concluded that time should not be thought of as a separate dimension of business. Time must be a key, integral part of any business offering. We also saw that objective reality is a mirage. If reality is a construct without objective underpinning, the way we think, our business endeavors, and our markets may determine our success or failure just as much as the other attributes we bring to bear. Chapter 8's fascinating journey into the micro-world revealed how strange and difficult to understand are the most minute portions of matter. In concluding our review of physics, we have refused to let quantum mechanics overshadow Newtonian mechanics. The new does not replace the old. Apart from the world of very small, subatomic matter, Newton's theories still work. And in business, it's quite possible to be very successful using Newtonian tools and disregarding everything else. However, the most important lesson from quantum theory is that apparently irreconcilable positions may just be two sides of the truth, that we should accept great truths as complementary even when they appear to be opposite. This means that in business, as in physics, there is room for the old view and the new one, for rational truth, numbers, cause and effect reasoning, and the mechanical view of the world, and also for unpredictable, probabilistic, experimental, unfolding, and paradoxical patterns of reality, about which we shall learn a great deal more as we look into the world of nonlinear systems in nature and society in Part 3.